Hello and welcome back to Cracking the Cryptic, and we're carrying on with 2 puzzles a day for now, so I hope that's of some benefit to you. Now, this Sudoku puzzle is from Dying Flutchman, quite an amusing spoonerism, and we've done 1 or 2 puzzles by them before, so I'm certainly expecting good things this time. Now, this is much more about multiplication than addition for once, so the little killer clues outside the grid are pointing at diagonals and giving the product of those diagonals. So what you get if you multiply the numbers on the diagonal together. And the regions in the grid all have a product of 24. So if you multiply all 4 of these digits together, and they can include repeats, you get 24. Now there's one other rule as well, which is that in no row, apart from where it's already been given in the givens in the grid, can you have these numbers appearing in sequence, so forming these 2-digit multiples of 24. So you cannot have 2, 4 up there, for instance, or 9, 6 there. So no row, apart from where it's already been given, can have 2, 4, 4, 8, or 9, 6. So I guess it's called 24/7, not just because of the givens in the grid, but also because there are 7 regions that multiply up to 24. Do have a go on the link below the video before watching the solve. I'm going to have a crack at it now. So let's get cracking. And these 2 multiply up to 8. So this region, to multiply up to 24, the others have to be 1 and 3. That's the only way to get there, I think. 504. That is surely the biggest multiple of 3 Sudoku numbers, 9, 8, and 7, or certainly 3 that you could get in the same box. I think that maths is right. Yes, it is. Yes, that is definitely right. That does not prove what goes in here, unfortunately. It could still be 1, 2, 3, 4, or 1, 4, 6. I think there are 3 different ways of multiplying to 24 with 3 different digits, which are going to apply in these regions. But 4 must be in there. Is that helpful? Not really. What about this 60? It's got to have a 5 in, but then 12 is either 2, 6 or 3, 4. Yeah, 12 is either 2, 6 or 3, 4, so that must be what's going in there. In this 40, got to have a 5 again. I was going to say it's got to be 5, 1, 8, but it could actually be 5, 2, 4. And it can't. Yes, it can. No, it can't be 5, 2, 4, because that would make this impossible. So we can take out 2, 4. That is definitely a 5, 1, 8 triple. I mean, this looks like very little that we're actually achieving here. 1, 3 is looking at that, so that can't be the 1. How do we do anything else? Yeah, that 2 and 4 are looking at these. No, better, that 1, 3 are looking at those 2 cells. The minimum they can now be, therefore, is 2, 4 or 2, 6. And 2, 6, yeah, no, 2, 6 is impossible, because that would be 12. You'd need to make these multiply to 2, and they'd have to be 2 and 1. We've already had a 2 in the row. So these must be 2, 4. And let's not forget the rule. We cannot have 24 in another row. So that has to be 4, 2. I bet I do forget that rule later, but I remembered it for now. Now that means these other 2 are 1 and 3. That 2 does sort out the 12. And then we have 6, 7, 9 in the other 3 offset cells in the box. That one can't be a 7 because of that. Okay, well that's something, but not much. Now that 2 is looking at that cell. Now what? Okay, if this was 2, 5, 6, then this can only then be, can't be 2, 3, 4 or 1, 4, 6. So it can be 1, 3, 8 if that's 2, 5, 6. Now the other alternative of this is 5, 4, 3, and then this would, I don't think there is anything it can be. 1, 2, 6, 8 are the only factors of 24 left, and they can't go together to do that in a 3. Brilliant, okay. So this is not 5, 4, 3, it's 2, 5, 6. This is 1, 3, 8, that must be right. Okay, so we have 7 and 9 must be there, because neither of them is a factor of 24, and 4 goes in the 24 region. Okay, that feels like it's a real deduction. Now, what can we do with the 4 in the 24 region? The other cells have to multiply up to 6. And you would think that has to be 1, 2, and 3, but actually, remember, repeats are allowed. So it could be 2 1s and a 6. If it's 1, 2, 3, though, this one's 1 or 3. Actually, this one's 1 or 3, because otherwise we'd have a 24. Oh, that's interesting. Now, don't assume that that's a 1, 3 pair now, making this one a 2, because that could be 1 and 1, making that one a 6. Ah, it couldn't be 1 and 1, because one of these has to be 1. So it is a 1, 3 pair, making that a 2. I don't know which way round the 1, 3 pair goes, but I know it's a pair. There's also a pair in this column. That means this can't be 1. That fixes the 1 in this diagonal. How peculiar. That means 1 can't be here. 1 must be in one of those. It feels like I'm sort of making progress, but not actually getting very far with it. Now, what can we do here? This definitely had 2 possibilities, 4, 1, 6, and 2, 3, 4. Leaves all sorts of possibilities for this. But what about 2? 2 can't be there or there. So it's either there or in that region. If 2 was here, if 2 was there, this region would be 4, 1, 6. This would be 3. That would have to be 1. And this couldn't be anything small enough to allow this sum to work, because 1, 2, 3, 4 would already be gone in the row. When I say sum, I mean this product. That would have to be at least 6, and that's too many now. So that can't be 2 by that reasoning. It would just not allow those 2 cells to be small enough to make this 24 region work. So 2 has to be in that group. They have to be 2, 3, 4. Sorry, let me just get that right. 2, 3, 4, yeah. 7, 8, 9. So these are 1, 5, 6. 5's obviously not in the 24 sum. Now, can that be 6 realistically? These would have to sum to product to multiply to 4, which would either be 2, 1, 2, and that's not possible to have a 2 there, or 1, 4, 1, and that's not possible for the 4. So that is a 1. Yeah, that 1 fixes 3 and 1 in that region. That fixes 3 and 1 in that region. I wonder if this is going to be 1, 2, 3, 4 like the other 4 cell regions, but we don't know yet. Or maybe we do. How could this be a 6 or an 8? If it was a 6, 1, 4, no, we can't have a 1 or a 2 in that row at all. Well, in fact, that's the absolute giveaway. This has to be 2, and these have to be 3 and 4. How remarkable. 3 and 1 are fixed up there. I could actually, with that 1, have fixed that 3 a while ago, which would have helped. But anyway, got there. And they are all 1, 2, 3, 4. So actually, that rule about repeats are allowed. I know we've done puzzles before where we've said, you know, that makes it almost certain there will be a repeat, otherwise that wouldn't be in it. But there isn't. That's quite a nice bit of deception by the constructor, I think, actually. Now, what else have we got? Oh, how about this? It doesn't include a 3 now, so it could be, well, it can't be 1, 3, 8 or 2, 3, 4. It's 1, 4, 6. That one isn't the one, obviously. 7, 3, 2 now in the box must be there because of that 2 and that 2. They rule out all of those cells. The other 3 are 5, 8 and 9 in some order. Does that 2 help? Now, I've forgotten this rule entirely about the 24s, 48s and 96s. Now, maybe it won't have mattered yet, but it's worth remembering it as I sort of reach a bit of a halt here in the deductions. I can't see where that's immediately helping me actually, but let's try and not forget it. What else can we do though at this point? That's the sort of thing oh, 2, look, 2 and 2. 2's got to be there, given all these 4 2s looking into that box. 1 and 1. Oh yeah, we know one of those is a 1. Oh look, there's 1 3 there and 1 3 there. So this is a 1 3 pair. 1 4 and 1 4. So that's a 1 4 pair. 2. This happens everywhere. 2 3 and 2 3. So that's a 2 3 pair that has been resolved. Is this? Yes, 2 and 4. How peculiar. Look at that. If we'd been colouring all the numbers under 5, we'd have had a field day with that. Right, that 3 has settled the 4 3 order of the diagonal. That 3 makes this an 8. Oh, that 4 makes this a 6. That's important. That 8 can come out of there. That's 1 or 3. The 4 also does 2 4 there. Oh, don't say that's going to run dry. 1 3, 1 4. Oh no, look, 2s. 2 and 2. That's the 2. Oh, well, I could have done that already because those have both been reduced to 5 6. Okay. 2, this can't be 2. That can't be 2 either, actually, from the column. So 2 is fixed in the corner there. So we've got, oh, that's really weird. We've got this set of 5 pairs that form what would be a deadly pattern, but surely then one of them is going to be disambiguated by the extra rule. Yes, this one can't be 24, so that's the 3. And that sorts them all out. Okay, well, it was more by considering how I needed to use the rule that I found that, rather than actually noticing it, but that'll do. So that's got all the 1, 2, 3s and 4s done throughout the grid. Right, that's not an 8. Do I need this rule again to make anything further? Where am I missing it? So that can't be 48. Ah, 48 there. So that's the 9. Yes, that works. 7, 8. Surely that's helpful. This can't be 8 anymore. Nor can that. That's 7 or 9. 5, 6 pair there. Oh yeah, the 9 has sorted out 7 and 9. And that can't be 96. Brilliant. Yes, so that's fixed the whole box. That 5 fixes the 8 and 5 up there. 9 and 6 and 7, and box 3 is done as well. I don't know what that is. Irritating. That's 5 or 9. That can't be 5 and that can't be 9. This is 5 and 9 down here, and that means this isn't 9. Oh yes, that has already meant that's not 9. Right, in fact the 5 has sorted out the 6-5 pair. That sorts out the whole triple, so all of the corner boxes are now fully done. And, oh yeah, look at that 9 and 7. They're very useful. They're now ruled out of there. So they have to go in those 2 cells. Oh look, we're finishing off columns 7 and 3 anyway. So we could do the central cell is now a 5. Ooh, 6, 8 here. No 48, remember? So that is the 6. 8 there. 5 and 7. 6 and 9 down here. They're done. Where does 9 go down here? There. 7 there. What have we got? 5 and 8 here. We can do those. 7 and 5. Right, so just the central 3 up the spine. 5 and 7 there. 6 and 8 there. 6 and 8 there. So we've got to use this rule to disambiguate these last remaining 5 pairs. There it is, right at the top. That can't be 96. So 8 there, 8 there. That puts 6. Oh, that only does 2 of the rows. We've still got 3 pairs. Please work again. 96 down here as well. Brilliant. That's a lovely finish. I mean, it's a lovely puzzle. That's really clever. So there we go. Hope you had fun with that one. It's quite difficult keeping track of that extra rule, really. But a really well put together puzzle. Very entertaining. Hope you enjoyed that. Hope to see you again soon on Cracking the Cryptic. Let us know what you thought in the comments, and bye for now.